Module 5, Lesson 2 deals with adding linear expressions. The content objective says students will add linear expressions and express the sum in simplest form. Suggested pacing suggests this will probably be a 2-day lesson, so let's get started. The Amazon rainforest spans for 2,300,000 square miles and is large enough to fill the state of Texas over 8 times. That's a big bunch of forests, guys. New species of animals are constantly being discovered living in the rainforest. Over the span of just a few years, scientists discovered X new birds and 4x plus 8 new species of fish, and 3x plus 4 new species of amphibians, and 2x minus 14 new species of reptiles. And of course, scientists write it that way because they're weird, right? No, nobody really writes it that way, but the math is the book's trying to make it cool for you. How can you write and simplify an expression that represents the total number of species that were discovered during this time period? Well, you know it. These are the kind of things you're going to learn about in this lesson. Our inquiry question asked, how can you use a magic square puzzle to add expressions? Well, that's a really good question because I don't even know what a magic square puzzle is, so let's find out. Gives us this little thing about how to solve a magic square puzzle, so let's look at that. Maybe we'll learn something good. How to solve a magic square puzzle? You're going to take these numbers are algebraic terms, alright, and these numbers are constants, so your orange are algebraic terms, your greens are constants, and from there we're going to take and say that these expressions are the sums, so you got 3x plus 2x is 5x, and then 5 plus 1, that's going to be 6, going this way, 3x plus 5x, and 2x plus 1 is going to be that way. And then what do you have when you put it all together? Well, when you add the 5x, give me the 3x squared and the 2x, you get your 5x here. When you get your 5 plus 1, you get the 6 here. Same thing, when you add 5x plus 6, you get 5x plus 6. Okay, that's pretty simple. I think we can pull this off. How to use a sketch? Alright, we're going to use a magic square puzzle to find negative 10x minus 3 plus 4x minus 4. So we're going to take and, negative 10x minus 3, that is going to be the one we're looking for right here. So I got negative 10x, and then I need to go minus 3, that'll be over there. Right here, I'm going to have a 4x, I'm going to come way over here to be 4x, and a negative 6 right there. Going this way, I'm going to have negative 10x plus 4, so that's going to give me plus 4x, which is going to give me a negative 6x. Signs are different, find the difference. Here the signs are the same, find the sum. That's going to give me a negative 9, and then negative 6x minus 9x, that's going to become negative 6x minus, whoops, missed that. Negative 6x minus 9x, which is the same thing you go here. Negative 10x plus 4x, negative 6x, and negative 3 minus 9, that's going to give us negative 9. Check it. The answer checks. Alright, that's cool. We can do this. So now we have a new problem where they're getting really darn creative on us. Two expressions have a sum of negative 8x minus 1. And they want us to use a magic square to find the expressions. So we know that when you take and add going this way, you add negative 4 to something, you get a negative 1. So I'm thinking this one here, that's going to become a positive 3, because a positive 3 minus 4, that's going to give me a negative 1. And we know that we get a negative 8 here, so negative 3 plus what's going to become a negative 8? Well, that's going to become a negative 5. So I get negative 3x minus 5x, you bring it down, and that's going to be the negative 8x that we see right here. 3 minus 4, that's become the negative 1 that we see right here. Going this way, negative 3x plus 3, so that's become a negative 3x plus 3. And then this way, that's become a negative 5x minus 4. Check our answer, and the answer checks. How about you try this one on your own real quick, and then I'll come back and do it with you. So did you get it right? I hope you did. Let's figure out what we have here. This way is a 3x and an 8. So what goes in my x thing? It's going to be 3x because it says so right here. And what's my constant going to be? It's going to be 8. How do we know? Because it says so right here. Now going this direction, 3x plus something is 7x. That something has to, of course, be 4x. 3 plus 4 is 7. Right here, 8 minus 9, well, that's going to become a negative 1. And then for this one, 4x minus 9 is what's going to go here. So that's a positive 4x minus 9. That goes from this way. And then going across here, 7x minus 1. So we're going to come up here to 7x minus 1. And going this way, the 3x plus 4x is also 7x. 8 minus 9, that's also 1. Check your answer. The answer checks. Now I'll let you pause the video and do one more just for fun, and then we're going to get down into the meat of the lesson. So were you able to get it? Let's see what I did. First off, I know that this line right here is negative 7x minus 3, so I'm going to have a negative 7x and a minus 3. Going this way, I'm going to have negative 7x plus 1x. Well, that's going to leave me with a negative 6x. And here I have negative 3 something equals negative 6. That's going to become negative 3 as well. Negative 3 minus negative 3 is negative 6. Now it's a matter of going to the right. 1x minus 3. 1x minus 3. And then negative 6x minus 6 is negative 6x minus 6. From there, I'm going to check my answer, and the answer checked. Easy math. All right, enough of this exploring. Let's get busy actually learning some cool new concepts. So now we're moving on to the learn, add, and linear equations, which defines a linear equation as an algebraic expression in which each term is a constant or a product of a constant and a variable raised to the first power. That's the big deal right there. Your exponent cannot be anything greater than 1. If your exponent is greater than 1, it's not a linear expression. So here they've given us some examples. 3x plus 2, there's no exponent greater than 1, it's linear. 5x, there's no exponent greater than 1, it's linear. Here you have x to the 4th minus minus 7. That's not linear because of that exponent 4 here. And this one has two variables, and since you have two variables, it's not going to be linear as well. Now you take a minute and group those on your own, put them in the right piles, check your answers, and I'll join you in a second. Well, let's take a look. This one has an exponent of 2, so that can't be 1. This one has an exponent of 3, so that can't be 1 either. But the rest of these are just single variables with an exponent of 1, so I'm pretty certain that all of those are indeed going to end up being linear expressions. Nope, they said divided by 6. Let's see why. Because it says that you have to have a product. This is not a product. That is a quotient, the answer to a division problem. So we're going to drag that one, put it in there. Now we have correct answers. And it is animation time, where the textbook is going to give us a video.
You can add linear expressions by combining like terms. First, rewrite each subtraction as addition by adding the opposite. Then arrange the like terms in columns. Next, add the like terms in each column. Add the like terms with variables, then add the constant terms. You can rewrite addition of a negative number as subtraction. You have now found the sum of the original expressions.
That's a really good way to do it, using the columns. It helps you to group things, and it works well unless you end up having nonlinear equations or things that you're missing values of, like maybe you didn't have a constant in the first one. If that happens, things do tend to get a little bit confusing. So let's go ahead and work on example 1 together and see how it works. So we're going to find the sum of 4x minus 2 and negative 7x minus 3. Moving through this, we're going to take and start off by making the pretty problems ugly, just like they said. Oh, nope. Instead, they want us to use algebra tiles to model it. So we're going to model each expression. So the first expression is 4x minus 2. So I'm going to have 1, 2, 3, 4 x's, and then minus 2, minus 1. Whoops, wrong thing. Minus 2. Your second expression is negative 7x minus 3. So we're going to do 1, 2, 3. Oh, was that a negative 7? That was a negative 7. So I need to get rid of those and make those into negative. So 1, 2, come on, give me some room to work here. 3, 4, 5, 6, 7. So I got negative 7x and then minus 3 again. So that's going to be minus 1, minus 2, minus 3. Now it's time to get rid of the zeroed pairs in here. And what zeroed pairs can we get rid of? Well, these two right here. So I'm going to take that one and throw it away. I'm going to take that one and throw it away. I'm going to take this one and this one. And then I'm going to take this one and this one. And I'm going to take this one, maybe, and that one. And now what are we left with? We're left with negative 3x's and 1, 2, 3, 4, 5, negative 5. So your final answer is going to be negative 3x minus 5, and I'm not real sure where they want us to put that. Maybe in the next scene. Nope, apparently not. Here it is. So this is where we're going to put our negative 3x minus 5 and check, and the answer check. That's how you would do the problem using the algebra tiles. Now we're going to do the problem the way they showed in their animation, where we're going to be using the columns. We have the same problem here, and the first thing they're going to have to do, of course, is make that pretty problem ugly. So making the pretty problem ugly, we're going to scroll down, and we're going to start off by making the pretty problem ugly, where we had a minus 2, that's plus a minus 2. Where we had a minus 3, that's plus a minus 3 now. From there, they're going to align them in columns, so we get 4x plus a negative 2 and negative 7x plus a negative 3. Now, if it was me doing it, I would do something a little different, but we're going to do what the textbook says. So from here, positive 4x minus 7x, what's left? Well, that's becoming negative 3x. And here I have a plus a negative 2, also known as minus 2, a plus a negative 3, also known as minus 3. When you add these negatives up, you get plus a negative 5. And now the last step is to make that ugly problem pretty again. Plus a negative, that's the same thing as minus, and you can type that answer in, negative 3x minus 5, and check, and the answer checks. Alright students, now it's your time. Pause the video. You can use algebra tiles if you want, but if it was me, I'm just saying let's not even bother with algebra tiles. You go straight to using columns to solve this problem. Did it check well for you? Let's see how I'm going to do it. I'm going to make my pretty problem ugly first. I'm going to have negative 3x plus a negative 8 plus 6x plus a negative 12. Notice my double parentheses there. From there, I'm going to take and realign these. So I'm going to have negative 3x plus a negative 8, and I'm going to have 6x plus a negative 12. Put my line in, 3x plus a positive 6x. The signs are different. Find the difference with a sign for a larger number going in front of your answer. That gives you 3x. And then right here, my signs are the same. Find the sum with a sign for the larger number going in front of your answer. That gives you negative 20. Last step, make that ugly problem pretty. 3x minus 20. That should be your final answer. Jump back over here, plug it in, 3x minus 20. Check. Uh-oh, what did I do wrong? I did do something wrong, didn't I? I missed the fact that that's a plus 8, not a minus 8. So this one right here, we're going to leave that as just plus 8. And because of that, we're going to have signs are different. Find the difference being -4. And that means that my final answer here is also going to end up being a -4. So let's go back and try and plug this in correctly now. Do 3x minus 4 and check. Now my answer checks. Sometimes those stupid writing errors will get me in trouble. This is a good spot to go ahead and stop video 1. We're going to come back for part 2 where we only have 3 resources left to cover, so it should go pretty quick. See you in the next video.